In this video, we will discuss what reduced row echelon form is and how to obtain it using elementary row operations. A matrix is in reduced row echelon form if it satisfies the following properties. First, it is in row echelon form. Second, the leading entry in each non-zero row is a 1, called a leading 1. And each column containing a leading 1 has 0 everywhere else. The following matrix in example 2.10 is in reduced row echelon form. Notice that all the conditions of a row echelon were satisfied. Also, the leading entries of the non-zero row is 1. And each column containing a leading 1 has zeros in its column. It is important to take note that the reduced row echelon form of a matrix is unique. That is, we can only get one reduced row echelon form for every matrix. To convert a matrix to its reduced row echelon form, we still apply the three elementary row operations. For instance, let's consider example 2.11. Remember that this matrix was our example in the previous video, and the row echelon of the matrix is given by 1, 0, 0, 0, 2, negative 1, 0, 0, negative 4, 10, 1, 0, negative 4, 9, 1, 0, 5, negative 5, negative 1, and 24. Now, let's solve for the reduced row echelon form of this given matrix. The first thing that we will do is we will convert every leading entries in this row echelon matrix to 1. Notice that the leading entry for row 2 is negative 1, and the leading entry for row 4 is 24. So we need to do something about it. To convert this to positive 1, all we need to do is to multiply row 2 by negative 1. And that is negative R2. To convert this to positive 1, all we need to do is to multiply row 4 by 1 over 24. That is 1 over 24 times row 4. Therefore, the new matrix is 1, 2, negative 4, negative 4, 5 for the first row. This is 0, because if we multiply 0 by negative 1, the result is 0. Negative 1 times negative 1 is positive 1. 10 times negative 1 is negative 10. This is negative 9, and this will become positive 5. For the third row, we will copy the components. 0, 0, 1, 1, negative 1. And for the fourth column, we will multiply every components by 1 over 24. So this is equal to 0, 0, 0, 0, and 24 times 1 over 24 is 1. Now the next step is to check every rows with leading 1. So this one, this one, this one, and this one. For the first column, actually we don't have any problems with it. Every other elements or components for these columns are 0. However, for the second column, we still need to change this one to 0. We can do that by performing the operation R1 minus 2R2. We will write that rule here. So that's R1 minus 2R2. So the new components of the first row is get the first element of row 1, that is 1, minus 2, times the first element of row 2, which is 0. Perform the operation. This is equal to 1. For the second element, we get the second element of row 1, that is 2, minus 2, which is the constant, times the second element of row 2, which is 1. And this is equal to 0. Next, third component of row 1, which is negative 4, minus 2 times third element of row 2, that is negative 10. Perform the operation. This is positive 16. Next, the fourth element of row 1, which is negative 4, minus 2 times the fourth element of row 2, which is negative 9. Perform the operation, we get 14. And finally, the fifth element of row 1, which is 5, minus 2 times the fifth element of row 2, which is also 5. Perform the operation and we get negative 5. We will just copy all the components of the other row since we are not doing something about it. Notice that the second column now is good to go. Next, we will consider column 3. Since this contains a leading 1, we need to change this and this to 0. So we will manipulate row 1 and row 2. So let's focus first on row 1. For this to be 0, all we need to do is to perform this operation. R1 minus 16 R3. So notice I used the leading entry for this column. So the first element of row 1 is 1 minus 16 times the first element of row 3, that is 0, and that is equal to 1. For the second element, we have 0, that's the second element of row 1, minus 16 times the second element of row 3, which is 0, that is 0. Next, we have 16, the third element of row 1, minus 16 times the third element of row 3, which is 1. So this is equal to 0. And for the fourth element, we have 14 minus 16 times the fourth element of row 3, which is 1. So this is equal to negative 2. Finally, we have the fifth element of row 1, which is negative 5 minus 16 times negative 1, which is the fifth element of row 3. Perform the operation, and this is equal to 11. Also, we need to change this one to 0. Therefore, we can do that one by performing this operation. That is R2 plus 10 R3. So the first element of row 2 is 0 plus 10 times the first element of row 3, which is 0. Perform the operation. This is equal to 0. Next, second element of row 2, which is 1, plus 10 times second element of row 3, that is 0. Perform the operation, and this is equal to 1. Third element is negative 10 plus 10 times the third element of row 3, which is 1. So this is equal to 0. Next, we have negative 9 plus 10 times 1. So this is equal to 1. And finally, we have 5 plus 10 times negative 1 here. So this is equal to negative 5. For row 3, we copy the components. That is 0, 0, 1, 1, negative 1. Same with row 4, 0, 0, 0, 0, 1. Now, column 1, column 2, and column 3 are good to go. For column 4, since we don't have a leading one here, therefore we will leave it as it is. So what we need to do now is to change this, and this to 0. Let's first consider 11. We can change this one to 0 by performing this operation. R1 minus 11, R4. If you see the pattern, actually what will change here is only the fifth element of row 1. So we need to copy every element here, that is 1, 0, 0, negative 2, and perform this operation, that is 11 minus 11 times 1. So this is equal to 0. Next is we will try to change this one to 0. So we can do that one by performing this operation. R2 plus 5R4. Similarly, all we need to do is to copy these elements except the last component. So we perform the operation, that is negative 5 plus 5 times 1. So this is equal to 0. Finally, we will change this one to 0. And we can do that one by performing the operation R3 plus R4. So we copy these elements here, 1, 1, 1, and perform the operation, that is negative 1 plus 1. So this is equal to 0. And finally, we copy all the components of row 4. Therefore, this matrix here is the reduced row echelon form of the original matrix.